Good morning or good afternoon, depending on the time when you watch this. So, from the College Board, I took two free response problems from Unit 4, and I'm going to do those two problems for you right here. So the first two sentences right here, or three sentences, basically it's the kind of things that are written in general on the AP test. Okay, the problem really starts right here. Okay. So we have a piecewise function, wt, that is defined that way when t is between 0 and 6, and that way when it's between 6 and 10. Okay, and the depth of a river at a certain point is modeled by that function w. Okay, so it's measured in feet and time is measured in hours. First question, find w prime at 8. Okay, so the fact that this number is 8 here tells me that I'm going to be over here. All right, which means that to find w, I'm going to take the derivative of this part of the function. So I'm going to have w prime of t. It's going to be negative 1 over 5. Okay, then it's going to be 2. Then it's going to be t minus 6 exponent 1. And then it's going to be times the derivative of the inside, which is 1. Okay, so it's just going to be negative 2 over 5 times t minus 6 like this, which means that w prime at 8 will be negative 2 over 5 times 8 minus 6, negative 4 over 5. But what are we talking about really right here? Well, remember w prime of t is equal to dw over dt, right? And w, whether it's a small w or a big w, represents here the depth of the river measured in feet. So this is going to be feet divided by, and the time is in hours. Okay? And so this is going to be feet per hour. Okay? The depth of a river at a certain point is modeled by the function w defined above, where w is measured in feet and time t is measured in hours. Okay? So the depth of the water at a certain point is changing. Anyway, here we are, we have this. Using the correct units, express the meaning of w prime at 8 in the context of the problem. But that means that at that point of the river, at that point where things are measured, at that point of the river, when t equal 8 hours, the depth of the river is decreasing at a rate of negative 4.5 feet per hour. Yeah, that's it. That's the kind of answer that you need to give for this kind of things. I would be advising you to err on the side of caution and to write a full sentence. All right? All right, next. The graph of W is concave down between 3 and 3.5. That tells me that for all values of t that belongs to the interval like this between 3 and 3.5, we can say that W, the second derivative right here, is less than 0. Okay? And use the line tangent to the graph of W at t equal 3 to show that W at 3.5 is less than or equal to 9. Okay? So when t is equal to 3, the function we're going to use this time is going to be the 17 over 2 minus 3 over 2 cosine pi over t, pi over 6t. Okay, so we're going to say that W at t is equal to, let me read it again, 17 over 2 minus 3 over 2 times cosine of pi t over 6. Again, because we are between 3 and 3.5, and we know already that if we are between 0 and 6, it's going to be like that. Okay? So, use the line tangent to the graph at t equals 3 to show that W at 3.5 is less than 9. Okay. So, let's study the line tangent to the graph. Okay. So, let's do it here. The line tangent to W t at t equals 3. Well, that's going to be equal to y minus W at 3 equal W prime at 3 times, and y is a function of t, right? T minus 3. Okay, this is just the point slope form right here. Okay. Since I'm going to run out of room right here, I'm just going to take this right here and I'm going to move it down to have a little bit more room. There you go. Okay, so since the function wt is over there, we can find w prime. So from here we can say that w prime at t is equal to negative 3 over 2 times the derivative of cosine is the derivative of cosine negative sine? Yes, it's negative sine, so positive sine of pi t over 6 times the derivative of the inside, and don't forget the chain rule, pi over 6. So it's going to be equal to, the 3 and the 6 gives me the 1 over 2, so it's going to be pi over 4 times sine pi t over 6. Okay? Therefore, if I write the equation of a tangent line, it's going to be equal to y minus, so we need w at 3. Okay? So w at 3, essentially I'm going to replace t by 3 right here, right? So 3 over 6 is 1 over 2, pi over 2. Cosine of pi over 2, remember, is 0. So it's just going to give me 17 over 2 minus 0. Okay, so 17 over 2 right here equal the derivative. It's just going to be pi over 4. If you replace t by 3 right here, that's pi over 2. Sine pi over 2 is 1. 1 times pi over 4 is just pi over 4. And then we're going to have t minus 3. Okay, so that's my tangent line. Okay, so y minus 17 over 2 equal pi over 4 times t minus 3. If you want, you can rewrite it as y equal pi over 4 t plus 17 over 2 minus 3 pi over 4. Okay. Does that help or not? I don't know, but here it is. And so, how is that useful? Well, let's imagine that this point right here that I'm drawing, is the point of coordinates 3 and 17 over 2. Basically, the point of on the function equal to this. Okay? And we are going to draw the tangent line. Now, the tangent line is the line that goes through this point, right? that has a slope equal to pi over 4. Okay, so pi over 4 is a little less than 1, so I'm going to draw a line like this. There you go. This is my tangent line. Tangent line. I'm not going to write its equation. We have it right there, but that's my tangent line. And the first thing that we were told right here is that the function is concave down, right? That means that if I were to draw the function w, I know that the function will be like this, y equal w of t. It is concave down. Okay? And so we need to prove here that when t is equal to 3.5, we want to show that the function is less than or equal to 9. So if we are at 3 right here, maybe 3.5 we're going to be here. We are not asked to figure out the value of the function right here. We don't really care about it. We want just to show that this is less than 9. So I have a hint, I have an inkling right here that what we need to do is maybe replace this value of 3.5 in the tangent line to see what's going to happen. Okay, so in this function right here, let me calculate y at 3.5 to see what's going to happen. So it's going to be pi over 4 times 3.5 is 7 over 2 plus 17 over 2 minus 3 pi over 4. Okay? So that's going to give me 7 pi over 8 minus 6 pi over 8 right here plus 17 over 2, which is essentially pi over 8 plus 17 over 2. Okay? Now, if I approximate those things algebraically, I know that 17 over 2 is 8.5. Pi over 8, let's round pi to being about 4 right here. Okay, that means that 4 over 8 is 2. 4 over 8 is 1 over 2, so 0.5. So we have 0.5 for this one. We have 8.5 for this. 0.5 plus 8.5 is 9. Okay, and so we know that this here is approximately 9, a little less than 9, because already we know that pi is 3.14, not 4, right? So we know that this value right here is less than 9. So this value right here, let me put it in red so that it's clear. This value right here, this is already less than 9. But we know that the function is concave down, which means that this value right here is even lesser than the previous one in red, so it's less than 9 as well, which essentially tells us that as a result, we can conclude for a fact that the function at t equal 3.5 is less than 9. Okay? So, therefore, w at 3.5 is less than 9. Now, what I explain right here verbally, you might have to write down a little bit more, but it's good enough for what we're doing here now. Okay, so that's for part B. Let me make a little bit more room by moving this thing down right here so that we can start with C. We have a limit right here. Okay, so we want the limit as t approaches 2 of w t minus t cubed plus 1 over 4 over t minus 2. Oh, look at this denominator. When t approaches 2, the denominator is going to approach 0. I wonder, right there in my mind, I'm wondering, am I going to have to use L'Hopital? But then I'm thinking, yeah, but it's unit 4, so maybe not. We'll see. Let's try to see what this is equal to. So the limit as t approaches 2 of w of t minus t cubed plus 1 over 4 over t minus 2. Okay, so t approaches 2. That means that I'm going to replace wt by the 17 over 2 minus 3 over 2 cosine pi over 60. So we're going to have the 17 over 2 minus 3 over 2 cosine pi over 6t minus t cubed plus 1/4 over t minus 2. So if I replace t by 2, right here, that's going to be pi over 3, right? And we know that cosine of pi over 3 is 1 over 2. So it's going to be the limit as t approaches 2 of 17 over 2 minus, we said cosine of pi over 3 was 1 over 2. So it's going to be 3 over 2 times 1 over 2, 3 over 4, minus 8 plus 1 over 4 over 2 minus 2, which is 0. Okay, so what do we have in the numerator right here? Well, we have negative 3 over 4 plus 1 over 4 is negative 1 over 2. 17 over 2 minus 1 over 2 is 8. 8 minus 8 is equal to 0. Oh, so essentially what we have, and I'm going to change the notation a little bit right here because we don't need this right here. Okay, but at this point, what I have is essentially 0 over 0. And you know what? We are studying problems here from Unit 3, but this is supposed to be a problem like the one we're going to have on the AP test. We know L'Hopital. We have studied L'Hopital. So this is an indeterminate form, which tells me that this limit right here will be equal to the limit as t approaches 2 of w prime of t minus 3t squared over 1. Okay, that means it's going to be the limit as t approaches 2 of w prime of t. So we did calculate it earlier, right? W prime was over there. So I'm going to grab it right here. Okay. So actually, I'm just going to grab this part right here. Well, actually, not even this part right here. There you go. Finally, copy, paste. Minus 3t squared, that's it, 3t squared over 1. Okay, so let's now replace t by 2. So it's going to be pi over 3. Sine of pi over 3 is root 3 over 2. So it's going to be root 3 over 2 times pi over 4 minus 3 times 2 squared. Okay, then it's going to be root 3 pi over 8 minus 2 times 2, 4 times 3, 12. That's, in my opinion, a very weird looking result, but I do not think that I made any mistake, so we're just going to give it a thumbs up and move on. Okay? All right. Next problem. One of the infamous particle problem. So what do we have here? A particle moves along the x-axis so that its position at time t greater than 0 is given by this right here. Okay, show that the velocity of the particle at time t is given by v of t. Okay, so for part A, we know that the velocity is equal to the derivative of the position. So the derivative of x of t as it relates to the time. Okay. So I think that this might call for a little bit of simplification. We could jump into the quotient rule, you know, with this expression right here, but I think I can factor this, and it looks like I might even be able to factor this. Can I factor this? It's a square, so maybe not, and this is not a multiple of 3, so yeah, probably not. So I think I might have to use the quotient rule. So what I'm going to do is I'm going to call this here the function u. So it's going to be u equal t squared minus 9. Therefore, u prime is going to be equal to 2t. I'm going to use v, the function v, for 3t squared plus 8. Therefore, v prime is going to be equal to 6t. And remember the formula. It's going to be, the quotient rule is u over v prime will be u prime v minus u v prime over v squared. So if I apply this formula, it's going to be u prime 2t times v 3t squared plus 8 minus u t squared minus 9 v prime 6t all over v squared 3t squared plus 8 squared. Okay? So, hey, look at that. Good news. We have a denominator that is exactly like the denominator that we are looking for. Good news. So let's try now to simplify. So it's a little bit of algebra. Simplify the numerator. Okay? So it's just a matter of taking our time right here. We're going to distribute. That's going to give us 6t cubed. Okay? And 16t. I'm going to change color so that we can stay organized right here. So you're going to have 60 times t squared is 60 cubed with the minus 60 cubed. And 60 times negative 9, which is negative 54t with the minus plus 54t. All over 3t squared plus 8 quantity squared. So let's go a little bit further. V of t equal. The two 60 cubed and negative 60 cubed cancel. 16t plus 54t is 70t over the 3t squared plus 8 squared, which is exactly what I wanted to do. So at this point, what I'm going to do is I'm just going to make a box right here, and I'm going to put a little square at the bottom right here to show that this is what I wanted to do. You can also see sometimes the letter QED, you know, but doesn't matter that much. This is just to show you that this is the result I was expecting, and so I'm done with that little problem. Okay. All right, let's look at part B now. Is the particle moving toward the origin or away from the origin at time t equal to? Give a reason. So I'm going to start by giving the reason. If v at 2 is greater than 0, okay, if v at 2 is greater than 0, that means that the particle, then it moves to the right. Right? And if v is negative, then the particle moves to the left, right? So basically, I'd like to know where it is at t equal 2. Is it to the right of it or to the left of it? And then where is it going? So what do I need here? Well, I need to know two things, basically. I want to know x of 2, and I want to know v at 2 in order to conclude. So x at 2, I'm going to replace up here. So it's going to be 2 squared minus 9 divided by, I'm going to have not enough room if I do it like this, 3 times 2 squared plus 8. So it's going to be 4 minus 9 over 20. So it's going to be negative 5 over 20, negative 4, right? That means that at the beginning, it's going to be to the left of the origin. So if I draw a number line like this, we can start right here at x equals 0. And when we are at x equal 2, so when we have t equal 2 right here, x at 2 is equal to negative 4, right? And v at 2 is going to be equal to 70 times 2 over 3 times 2 squared plus 8 squared. It's going to be 140 divided by 2 squared is 4, 3 times 4, 12, 12 plus 8, 20, 20 squared is 400. I don't really care what it is equal to. I just can say right here that v at 2 is greater than 0, which means that my particle is going in this direction right here. V at 2 is greater than 0, so that means it's moving to the right. Okay, so since it's moving to the right, but at that time it's to the left of the origin, then in order to answer the question, is the particle moving toward the origin or away from the origin, we need to say, therefore, in conclusion, the particle is moving, and it's clear on this picture, towards the origin. Okay? Let's highlight this little answer right here. Okay, we are almost done right here. Let's look at part C. Let me move this down right here a little bit more to get more room. All right. Part C. The acceleration of the particle is given by a of t. Write an expression of a of t and find a at 2. Okay. So a at a of t is equal to d v of t over dt. So the derivative of the velocity, and the acceleration, as you know, is the derivative of the velocity. And once we have that, we're just going to replace t by 2 in order to find the answer. All right. They are nice here. In case we made a mistake in calculating v of t, we can see right here that they gave it to us, right? So we can say it's equal to the derivative of, so we can say that v of t is equal to 70 t over, what is it? 3t squared plus 8 quantity squared. 3t squared plus 8 quantity squared. Okay. So we could use the quotient rule again. We could also use the product rule if you preferred. Doesn't really matter. It's going to be a little messy one way or the other because this is not an easy to deal with expression. So let's just use the quotient rule again. Okay. All right. Let's use purple this time. So I'm going to let u be equal to 70t. Therefore, u prime will be equal to 70. I'm going to let v be equal to 3t squared plus 8 squared. Therefore, v prime will be equal to 2 times 3t squared plus 8 times the derivative of the inside, which is the derivative of 3t squared since 8 is a number. Derivative of t squared is 2t times 3, 6t. Okay, so it's going to be 12t times 3t squared plus 8. All right. So u prime v, 7t times 3t squared plus 8 squared minus u v prime. So 70t times 12t times 3t squared plus 8 over v squared, which is 3t squared plus 8 to the 4th power. Okay, so are we going to distribute everything, expand everything, and everything? I really don't think that this kind of question is really in the spirit of the AP test to do a lot of algebra like this. So the answer to find an expression, write an expression, here it is, that's an expression. So now I'm just going to calculate a at 2. So I'm going to replace in this big expression over there t by 2. So it's going to be 7t times 3 times 2 squared 4 plus 8 squared minus 7t times 2 times 12 times 2 times 3 times 4 plus 8 all over 3 times 4 plus 8 all of it exponent 4. All right. So what do we have in the first parenthesis here? 3 times 4, 12. 12 plus 8 is 20. 20 squared is 400. And we have 70 times that 400. So we have 28,000. Minus 70, I'm going to do it on my calculator, times 12 times 4 times 20, 67,200 over, and that's going to be 3 times 4, 12, 12 plus 8 is 20, 20 exponent 4 is 160,000. So what do we have here? 28,000 we said, minus 67,200 divided by 160,000. So it's going to be equal to negative 0.4025. Okay. All right. Let's box this answer. I didn't really like this problem. It doesn't feel, like a real AP question. Yet it was created by the College Board. But, what you going to do? All right. Last question of this video. What position does the particle approach as t approaches infinity? So basically, the question is, what is the limit as t approaches infinity of the position? So we're going to take our position function right here, which was, we're doing this problem here, t squared minus 9 over 3t squared plus 8. So t squared minus 9 over 3t squared plus 8. Okay, so we know that as t approaches infinity, 9 is going to basically be insignificant in relation to the t squared on top, and that the 8 is going to be insignificant in relation to the 3t squared on the denominator. Therefore, when we look at this, we see that the t cancel, and we have an answer of 1/3. And essentially, that's really all we need to do for this here problem. Okay, so that was a very long video. I apologize for that. But at the same time, that gives you time to stop, pause, go get a drink, come back. Hopefully that was useful, and hopefully you're going to do very well on problems like this.